Um, I guess exam 3, right? Okay. So, just it's 8 pages long, is that correct? The key? And that, I want to make sure, are we talking about the December 11th, 2020 key? Someone just say yes if you can.
Yes, that's it. It's that one.
Okay, all right, so I have it in front of me. Um, but why don't I just go, if I can, to OneNote for a second here. Then I could take request. Okay, so I'll add a page, some lines on it, and try to share it. I'm having a little trouble sharing it, so let me see what's going on here. Okay, I finally got my OneNote working. Oh goodness, did I mess it up? Try it again. Okay, I assume you could see a blank sheet here. And I'll take request. Which problems on the sample test are you interested in? Or they could be problems from class problems, or they could be homework problems. So I'll take request. Oh goodness. It's not there. Request. Just give me problems, and I'll put down the numbers and we'll go from there. If there's anything on the sample test that doesn't make sense to you or you're not quite sure about it, it's a good time to ask. I think I heard
Hello?
somebody, but the volume was real low.
Oh, can you hear me?
I can.
Oh, okay. Can I request number 1, 5, and 6, please?
1, 5, and 6, is that what I heard?
Yes, please.
Very good.
Thank you.
You're welcome. Who else has a request? I mean, the sample test is there, but you may not understand it, or maybe you have a different way of doing it and just want to see if your way works or whatever. So I'm open to requests. Anyone else have any other requests? I've got one person who's requested 1, 5, and 6. I will be happy to do those, but let's see if anyone wants anything else.
Other people put number 5 and number 1 in the chat.
Okay, well, I'm going to vote on that soon anyway. So as soon as I get viable candidates here for problems to do, I'm going to ask which ones you want to see most, and we'll do the high demand ones first just in case people don't have a lot of time. But is there anyone who wants something other than 1, 5, and 6? How many problems were there on the sample test anyway?
There were 6.
There were 6. Okay. So
Number 3.
number 3 is come in with someone else. Good. Terrific. Okay. So so far I'm going to assume that 2 and 4 don't primarily interest anyone at this point. So let me see if I can just make a rough tally here. I'll try to do it so I can see people naturally. I'm smiling because when I want it to show all the windows, I can't get it to show all the windows. And the other times, so let me see what gives here. Okay, finally. Yeah, it's just odd. Oh, there we go. So, how many people have an interest in doing problem 1? Raise your hand or some way signal. So far I see, let me see, I see 4, 5. Okay, the hands are coming up front. So I see 5 people who want number 1. I'm sorry, I don't have, what was it? 1, what were the numbers again? What was after 1? Was 2 and one of the ones?
I think it was 1, 3, 5, and 6.
1, 3, 5, and 6. Thank you. So let's go to 3. How many people are interested in 3? Currently, I see 4 people.
I'm
Good.
interested in 3.
Okay, where's that? You were one of the
Alicia. I can't raise my hand. I can't find it.
Okay, so it's 5. So far this isn't doing anything. I got 5 for 1 and 5 for 3, so it's not helping me too much, but all right, whatever. How about number 5? How many people want to see number 5 or speak up either way? So it's almost the same 4 that I had before. Alicia, do you want that one too?
No, that's all right. I was just interested in 3.
Okay, so 4 for 5. And then finally, number 6. How many people have interest in that problem? Number 6 evidently is only 3 that I see so far. 4. So, okay, so it's pretty close. We have 2 5s and 2 4s. Let's do 1. I'll do 1 and 3 and go from there. Now, let me see if I can. This might be easier. How about someone helping me out by putting up, sharing the problem? So I will give you permission to share. If you can put up problem 1 for me. It doesn't matter who does it first, but I'm assuming you guys will probably get it faster than I could because I'm sort of booked here. Edgar's going for it. Edgar's, I see it. Great. So it reads random variable X of O. Number one, you don't have to worry about. We didn't get to it. Okay. All right. I mean, I could talk about it, but it's not going to be on the test because we just didn't get to it in class. So sorry. So what was after that? Oh God, that's pretty crazy. Was number three the one that was next?
Yeah.
Okay. If someone could put up three, there it is. Oh, there it was. Well, can you put it up again? It was there for a flash. I think Edgar's trying to do it, I believe. Jacob, I like your cat.
Thank you, Professor.
Yeah, sure.
Sorry, 1 second.
It's okay. I'm complaining about how long it takes me to put these things up. I can't say too much about anyone else who's trying to do it too. It says Edgar's Shrine.
Is it visible now?
Not to me, but maybe to others.
I see the screen.
Others see it. I think my screen has got so much load. Came from a review right before you guys, by the way. So this has been the day for reviews. Not for your class. This was a senior level class. Maybe I should try to share it myself. What do you think? So it's really odd. I mean, we had the first problem. Of course, that problem didn't have to be done. Well, let me see if I can.
Yeah, it tells me I'm sharing the screen, but I don't know if it's popping up for everyone.
It must be hiding behind. Let me take a stab that it's somehow hiding behind your pictures. I would think. Oh, yeah, I saw it briefly. So I think I might have been right. It might have been just behind something. Let me not be lazy and try to do it myself. But thank you for trying. I appreciate it. I don't know why, but I'm having trouble. You know what? Why don't you just read me the problem? I'm just going to go with what I can do. So Edgar or someone just want to read it to me?
Yeah, let me pull it up right now. It says for number three.
Please.
All right. It says two friends randomly arrive at an airport at a random variable at random variable times x and y that have uniform joint density on the following rectangle. And then it has a picture of a rectangle, and then it says calculate the probability of the absolute value of x minus y less than or equal to 1/4. And then I could describe the rectangle real quick.
Yeah, no, it's okay. I'm familiar with the problem. I'm familiar with the problem, but it doesn't seem to be helping me get to where I need to go. Let me see. Got too much stuff on and open. That's my problem here. If I don't be careful, I can actually lose all of it. Oh, I'm frustrated because I can see it, and yet it's not staying here. Finally got there. Sorry. Okay, Edgar, go ahead and describe the rectangle a little bit. Can you see me draw it?
Yeah,
Okay. So tell me where it starts and stops and so forth.
the boundaries for x are from 1 to 5, and then the y values range from 2 to 5. And so it starts at
Okay.
1, 2.
Yeah, hang on. I think I can catch up with you now. Is that roughly it?
Yes.
Okay. And it describes
It describes two friends randomly arriving at an airport at two different random variable times, x and y,
right.
and they have a uniform joint density.
Okay. And they want and this probability that the absolute value of x minus y is less than or equal to, help me, what is that?
Oh, 1/4.
1/4. So that's the same thing that we had in class. Okay. So this is essentially what we did in class, where we had two people meeting for lunch, and they were going to wait for 15 minutes or a quarter of an hour for each other. So what we need to do is see when they actually meet, when y equals x, that would be here at 1, 1, and this would be 5, 5. And so somewhere, let me see, and that would be 2, 2 would be over here, I guess. So what I've just drawn is the line y equals x. And it goes through the point 1, 1. And it goes through the point 2, 2. And it goes through the point 5, 5. And now being a quarter of an hour above or below that, so if I went a quarter of an hour past the 2 hour, that would be like 2 1/4. And if I went a quarter of an hour past this, it would be like 5:15. So I should have something that looks like this line. And on the low side, I should have something that looks like a quarter less than this. So maybe something like this and like this. Does that look roughly like the drawing that you have on the solution in front of you? That question's for anybody. Now I'm hearing
Yeah, it looks similar.
they look similar. Okay, good. So being within that 15 minutes means I want to be in here. Which is quite similar to what we did in class. The density is uniform. So what does that mean? That means the density for x and y will be a constant on this rectangle. This is the rectangle that I have drawn here. So it's a rectangle that's lower boundary is 2. So it's constant on this rectangle, and the rectangle starts at 1, 2. And goes to what? 5, 2 over here. And up to what? 5, 5 up here, I guess. So on here it's C and it's 0 otherwise. Okay.
Professor, real quick, actually, for the x-axis, the boundary for the x values it goes from 1 to 4, not 1 to 5. My
Oh, it goes
apologies.
1 to 4.
Yeah.
Thank you. Thanks for the correction. You know what? Maybe being a little lazy, I'll just label this 4. Okay. If I can get away with it, it doesn't look like 4 though. If that's 4, then 2 would be somewhere over here somewhere, I guess. Okay, but no matter. It's a constant on, so you're telling me 4 to 2 and 4 to 5, right? I'm assuming. Yeah, and that means my picture may be off a little bit. Let me see if I can draw this a little better. Well, even without the picture being drawn well, it's constant on this interval. Let's see. And so maybe it does more like this kind of thing. Yeah, it's really a shame I can't see my own picture from the key, but anyway. That would be 1, 1, and this would be 4, 4, I guess. Yeah, so the picture's not too good. Let me see if I can draw it better. Well, let's make sure I got this right. The corners are at 1, 2 and at 1, 5.
Yes, that looks right.
And so it looks like this. Okay, so with that said, let's figure out what the constant is. So the constant, the length of this, the dimensions of this rectangle are 3 this way and are, oh, is it a square, 3 by 3? Is that true? This looks like 3 from 2 to 5, looks like 3 that way, and from, oh, let's see, no, 1 to 4 also looks like 3. So this is a square, is that correct?
Yes, it just looks like a, a rectangle on the exam, I believe.
Yeah, but it should look more squarish. Maybe even more than that, whatever. So 5 is up here somewhere. Okay. So with that all done, so it's a 3 by 3 square, and on there, so the area of that would be 9, so the height would have to be 1/9, because we have to have volume underneath it to be 1. So is that something that everyone agrees with? That the constant would have to be 1/9? It's a 3 by 3. It may not look like it, but it's a 3 by 3 square. And so it looks like this. And for the height be such that this whole volume is 1, since this is 1/9. Well, since this area is 9, this would have to be 1/9 high. So the picture is poor again. Maybe more like this kind of thing. Okay. Now, as far as the drawing, when they still both meet, that would be at 2, 2, should be here. It would be at 3, 3. You can think of as being here. Or at 4, 4. Or at 5, 5. Oh, but there is no 5, 5. So let's think about this. 2, 2 is here. 3, 3 is here. 4, 4 is here. Wonderful. So okay. So I think probably what we would like to do is get the area in this region here and then multiply it by the height, and that would be the volume, and that would be the probability that you're within a quarter of an hour from 2 people landing. And that might not be too bad to do. I'm looking at it. Um, so one way to think of that would be to get this. If we look at the complement, we can go for this. That, and let me put this in polka dots. So that would be everything not where they're off by 15 minutes. Let's see what we can do in terms of finding the area of everything that's shaded. So since this is 3 by 3, it has an area of 9. And this much of it is somewhat easy. From this should be hitting at 2, 2, so the picture is a little poor. 2 is when they're both there at the same time. And so the shaded the part that's here. So I don't know. I think by trying to recreate it and taking more time on this than I want to. And I'm a little annoyed because I have a picture, I just can't see my own picture. Let me see. I'll give it one more chance to see if I can recover my own picture because I'm not happy with the picture I have here. Sorry for the delay. It's a technical problem, actually. I can't see my own picture. But let me see if I can bring it up. I'll try one more time. Yay. Okay, I've got my own picture now. Uh, so now let's make sure you can see what I can see. Okay, so I just want to share that. Boy. It shouldn't be this difficult, but it is. I'm almost ready to quit the problem. I had the picture, I tried to share it, and it's not letting me. If I get the picture again, I'll just record it again. Yeah, this is frustrating because it shows me the picture. What page is it on, Edgar? Is it on page 3?
For the key or for the regular, for the question?
For the diagram, for the one with the graph. The solution set.
On the key, it's on page 2.
Okay, let's try that. Okay, so I have the picture in front of me, which I've had now several times, but it's not letting me share it with you for some reason. So I'm just going to draw it again from this picture. But thank you for telling me where it was because it wasn't coming up. 3/4. Can you see the picture?
Yeah, I could see the picture.
Wonderful. Okay. Now, but at least we got over the technical difficulties of having the picture. But now I'm not sure about the picture. So now we're finally getting to the math. Okay, so let's look at this thing. This condition is the key. X and Y have to be less than or equal to a half, less than or equal to a fourth. And the way I've got it drawn here, it's 3 by 3, which I guess is fine. And the region that we want is everything. Oh my goodness. No. This is crazy. That's not the one I want. I thought it was. Okay.
Okay, yeah, I see the solution one.
Phew. I'm going crazy here. Okay. All right. So now let's look at this. This looks different than what I had before. That's why I'm saying there's two problems here. There's the technical problem of being able to get this picture on the board. At least it's there now, and you have it on your own thing. Assuming this is correct, this is not what I had when I was doing it without looking at the picture. So let's just look at this situation. This is a square, but it's not 3 by 3, it's 2 by 2, right? Okay. So of course, I don't have the rest of the problem, but I'm assuming that this is correct. I'm assuming that I still want x minus y to be less than a fourth. And if that's the case, let's just make sure some of this makes sense. Yes, this point up here, where the little plus occurs, would be 3, 3. And that's where y equals x. This point over here would be 2, 2. And the line connecting that would be when they're there at the exact same time. So I think that's correct. And what we want is everything that's not lettered. So we want a 1, a 2, a 3, and a 4. Because we think that some of that is easier to get than trying to find the area in this slanted interval. Wonderful. Now it's turned blue on me, but I guess I can live with that. Okay, so which is the easiest one? Maybe A1. A1 is the triangle that's a right triangle that's 3/4 by 3/4. And by the way, yeah, so we're just finding the areas at this point. So what's the area of the triangle A1? It would be 1/2 base times height, which is 1/2 times 3/4 squared. That's the area of A1. Any problems with that? That's pretty easy to recognize a right triangle that's isosceles. Okay, what's even easier, I suppose? A2, right? A2 is a rectangle. It's 3/4 wide and 2 long. So it's got a little smudge there, but it should be 3/4. And how do we know that's 3/4? That's a good question. Because the line that's over here, let me see, how do we know? Yeah, I think we know that because basically, let's see if I can show you with the picture. The distance from here to here would be 1/4 because this is when you're exactly there at the same time, and this would be when you're off by a quarter of an hour, which is 15 minutes. And the distance going up here, which is 1/4, would be the same as the distance going to the left. So that means that's 1/4, and this whole distance from here to here was 1, so that makes this 3/4. So A2 is 3/4 by 2, and it's got a little smudge there on the key, but it's there. So 3/4 times 2 is the area of A2. Does everyone, oh, I got rid of the color, good. Does everyone see the dimensions of those two? A1 and A2 are the easier ones. One is a triangle, and the other one is a rectangle. I think the next easiest one is A3. Now, A3 is a right triangle as well. And you can see that it's going from this corner up to there. So this distance would be 1. So A3 has one length side equal to 1. And then this other side, to think about it a little bit. Well, the 1/2 is from the triangle. That's easy. This side is 1. So the other distance here is also 1. And I guess that follows because this line is again making a 45-degree angle with this. So this is an isosceles triangle, which means the two sides are the same length. They're both 1. That's involving a little geometry. Okay, so we've got A3 has area 1/2 times 1 times 1. And now look at this little triangle, which is not to be considered because we're looking for the complement here. So A4 is probably the trickiest of them all. It would be the area of this rectangle. The rectangle would be what? 2 units. Well, let's see. From here to here is 2 units, so it'd be 1 unit high. And we're saying this, yeah, this distance from here to here was 1. And these two are the same. So those are each 1/4. So that's 1/4. Which means from here to here is the 1 again, plus the 1/4, which is the 5/4. So that's that one. Let me make sure. No, we already had A3. We're doing A4. So A4, since the distance from here to here is 5/4 and the distance from here to here is 1, 5/4 times 1 is the area of this whole rectangle. And we're just making it less the area of that little triangle in the right-hand lower corner. That triangle in the right-hand lower quarter is also a 45-degree triangle. So it's 1/2 base times height, and we're saying that the height of each of those is 1/4. Is that clear? Trying to make sure I believe it myself. So the only part that I'm wrestling with now is this minus 1/2, 1/4 squared. But I do think the dimensions of this little right triangle here, the sides are the same because this is 45 degrees for sure. So the sides are the same. The only question is, are they 1/4? I think so, because the whole distance from here to here should be 1 1/4. And that's saying the distance from here to here is the same as here to here, which is 1/4. Okay, so all of them are right. And now what do? Now you add up all the areas. All these areas are not in the region you're after. So you simply add them up, and I think that's all that's going on here. Let me make sure of that. Yeah, minus the 1/32 is this one comes with a minus. Everything else is plus. So assuming the arithmetic is done correctly, this then adds up, I suppose, to 112 over 32. But what is the area of the whole thing? The whole thing is just a 2 by 2 thing. Is it 2 by 2? Yeah. And I'm not sure about the final part of it. Let's see. What is 112 over 32? I can't quite make that number out. So 112 over 32 is the same as what?
3.5.
So that's what that number is saying, 3.5, and the whole thing was what?
Uh,
Four.
right? It's 2 by 2.
Or, yeah. So it would be 4 minus 3.5 is just what, 0.5, right? And then you have to divide, but that's the area. And then you have to divide by the 1/4, because the 1/4 is the density, right? Because this whole thing is 2 by 2, so it wouldn't be 1/9 like I had earlier, but it'd be 1/4. So that's where you're getting the 0.5 divided by 4, which turns out to be 1/8, which turns out to be the answer. Okay, a lot of technical difficulties and some mathematical difficulties too. It's tricky. Now, does anyone have a question about how this went? I could almost read your mind. Is this going to be on the test? Well, it was on the test, but I don't think we did as much with this as the class that had this stuff. You just had this the last day of the semester. And it's similar to the problem that we did in class, but it's a much harder version. So I don't think you'd see something quite this nasty. But hey, we did spend some time going over it. So any questions on it? Some things I have to correct. The original picture I had was 3 by 3. This picture is 2 by 2, which means the joint density is what? 1/4 instead of 1/9. Did I lose you anywhere? Okay. If not, let's move on. Okay. So what else was there? This is what? 3, I'm assuming? Yeah, 1 we disqualified because we didn't get there. 3, well, there's 3A. How about B? B is this, which looks much more innocent. I don't remember the wording that led up to it, but I'm pretty sure you want to know the probability. I'm guessing you want to know the probability within being within the 4 quarter circles that are in the corner. So pi r squared would be, if this is uniform, this whole region of 100 by 200 would be, that's the 20,000. So that's the density of the thing. And then but it's uniform, so you can just simply find the areas of those 4 circular portions. But those 4 circular portions can be put together into one circle. And if the radius is 50, the area of a circle is pi r squared. So this seems so much nicer than the previous one, but it's still part of the same problem. Pi r squared is the area within the 4 circular sections over 20,000. So I guess the chance of being in those circular sections is almost 40%, 39.2699% decimal. Any questions about B? I think B, well, okay, which is harder, A or B? I think A was. Because you had to worry about these little triangles here, things, right? This was pretty much, you just had to deal with the areas and the corners. But there's 4 of them, and you can see it adds up to the area of one circle. So for my money, I think B would be more likely to see a problem like that than probably A. But again, A was a spin-off of a problem in the class. Either way, any questions more about this? Yeah, Edgar.
I know that the key for the exam says that there's a part B, but I'm looking at the actual question for 3,
Uh-huh.
and it only asks for the like the probability that it's under a quarter. Like it doesn't really say part B on number 3. So I was just wondering where the second part.
Where it even came from.
Yeah.
I will try to look at the key again, see if it's there. What you have well, the key may be different than the test. You have the test.
Yeah.
What does it say on the test on problem 3? Is there
It
3B?
there's no 3B, it just asks for the probability of x minus y being less than a fourth.
Oh, I don't know. That's strange, because the solution set has this connected with it. So what it could be that the solution, that maybe I took the original problem and added this problem to it and put it in the key. And it may be a question that didn't appear actually in your sample test. Okay, so what would the question have been? Let me back up. The question would have been something like this. You have a floor space that's 100 by 200. It's a rectangle. And maybe the exits are in the corner. But it's a big, it's like a warehouse, maybe. 100 by 200 is not a small place. Okay. So you want to know the probability, if you're uniformly located in this floor somewhere, what's the probability you're within 50 feet of the exit, assuming the exits are in the corners. And so 50 feet within the exit would be a radius of 50 feet from each corner space. And that's where you're getting the circular sections. And so then assuming the uniform probability, it would just be what basically it becomes an area problem again, except you have to multiply by well, the density is 100 times 200 in this case, so it's 1/20,000. So in order, if you get the answer in terms of the areas, you have to modify it by dividing by 20,000 because that's the joint density of being in the rectangle. But the question probably was along the lines of, if you're in this rectangular warehouse or dance floor or whatever it is, and the exits are in the corner, what's the probability that you're within 50 feet of an exit? That probably was the question. Yeah, sorry for the confusion in that way too. Okay, what's left? 5? I believe,
Yes.
is that right?
Yeah.
Okay, now do I actually have 5 in front of me? Let's be optimistic. Maybe I can actually see the solutions. I will leave this. And I will try to get back to my email, for example. And that would be stat 2200 exam 3 again. And the key, I'm just looking at the key. What page is it, Edgar? Is it 5?
For the key?
No, for the question, problem 5. If you don't know, I can
Page
just,
3.
oh, it's just on 3.
So on 3 and 4.
It's okay. Let's see what's on 3. If it comes up. Okay, so on 3, I'm seeing nothing on my 3 except for 4A. Is there more than that? I don't know. Let me go to 4. I'm just looking at. So I see 4 now, but I don't see problem 5 there. So I'm going to put page 5. Maybe I'm on a different key than you are. Still don't see it. Let's go to page 6. Okay, I've got problem 5A, but I don't know what the problem is because this key was just made up without reference to the problem. So let me describe what I have. I have, what do I have? Yeah, so I'm sort of mystified too how to describe what I have for 5 because I don't know what the original problem was. I have an A, B, and a C. No, an A, B, and then sort of an afterthought question about are they independent? Is that what you have for 5? So the good news, okay, let me share what I have for 5 and see if it makes any sense to people. I will shut
I
this.
believe it's the same question.
Okay, but I don't have the question. Do you have? I probably sent you that's the original test, right? So probably you guys have it somewhere.
Yeah.
Let's see if I can share what I have here. think this is what I had. Okay, I'm hopefully sharing problem 5. Is that what you have in the solutions too?
Yes.
Okay. So I'm not sure what the original question was, but I'm guessing. Let me see if I can guess even. I'm guessing you were given a joint density that looked like CX, and
Yes.
it was over a triangle. Does that sound right?
Yes. On a one-to-one triangle, pretty much.
Yeah. So all right, and I'm just inferring that from the solution. Okay. I don't seem to have the original question I sent you, but let me double check. So it would be y equals 1 minus x would be like, it would be like a triangle that's going. All right, so I think I can show you what it looks like. Yeah, I don't want to write on this, but let me write down and then I'll just transfer it over if I need to. So I think I know what the original question was. I think it's a triangle that is a right triangle, and it goes from 0 to 1 on the x-axis and 0 to 1 on the y-axis. And it has the line y equals 1 minus x as the hypotenuse. And probably the density was given to be c times x.
Yeah, that's the question.
That's the question. Okay. Well, if that's the question, part A here deals with finding c. And this is how you set up, this is a little bit harder problem. You're not integrate. First of all, you're integrating. You're not finding areas like the previous two problems, the circular one and the one that took forever. This one is saying, let's find C. So I'm integrating over the triangle. And so maybe, let me see if I can go away from this for a second. So here's a question. Do people understand how I got the first step? Y 1 equals this double integral CX dy dx? Or is that part of the question?
For part A, it's just asking to determine C,
That's that's correct. But
the area would just be 1 because that's the total area under the graph, right?
that's correct. It's a density function. So the density lives on the triangle, which I already described. And so let me see if I can, I'll make an attempt to leave this for a moment. I hope I can come back to it as easily as I got to it. Stop sharing. I will go to my OneNote again. Okay, that seems to be working. So okay, I'm laughing because I can't believe that. Hang on. Okay. So here's the picture. That's the region. This is the x-axis, this is the y-axis. I didn't draw it that well. This is distance 1, this is distance 1. So this line is the line y equals minus x because it has a -1 slope, and plus 1 because it goes through the y-axis right at 1. So this is the region. The joint density probably was given to be C times X when what? When X, Y is in this triangle, called the triangle T. Or if you want to say it in 0 otherwise. Now, I'm not sure if the original question asked it that way. There's a different way it could be asked. You could say it could have been asked this way. Cx when x is greater than or equal to 0. And I'm trying to think how else I could have asked this. Well, why don't we just leave it this way, unless you tell me that it was asked. You want to tell me how it was asked? Because I don't have
So
the.
the way the condition was given, it was just like it said CX when, and then it was just a smaller picture of the graph.
Oh, wait, oh. What,
So you kind of had to infer the function from looking at the graph.
for x, y in this triangle. Is that what it was? Is that what I had? Something like that?
Yeah, it said CX on, then it says on the triangle, like, and
On
then
the
it's just
triangle.
at the
Okay,
graph.
all right. So I just, yeah, that's equivalent to this. Okay. So both of them, both ways of writing it, either that way or this way, really means that the region in which this density lives is T, the triangle here, and the triangle looks like this. Now, somehow you had to come up with the line itself for the hypotenuse, but that's not hard because it's a straight line and it's going through 1 and 1. And so you know 2 points, you can find the equation of the line. It's pretty clear it's got slope -1 and it's got y-intercept 1. So that's the boundary. Okay, so what does that tell you? That tells you how to find C, because if you double integrate the joint density over that triangle, which I'll just write this way, dy dx, say, you know that should equal 1. And so now the question becomes, how do you integrate over a triangle like this? Well, you have the border already. We've already figured out that it's 1 minus x. So if you're integrating the y direction first, I would be going from 0. Here's the picture. I would be going from here to here. So you're going from y equaling 0 to y equaling this line, which is what? 1 minus x. You're integrating this dy. And then where do you have contributions? Everywhere between, where do these arrows? Everywhere from 0 to 1. So that gives you the outer limits. So it could be, people are asking me to do this problem, it could be difficulty from remembering how do you integrate over a triangle from Calc 3. But if you can get to this, which is what you're doing, and by the way, you don't have to integrate dy first. You could integrate dx first if you wanted to. You could go from here to here. And that integrating dx then you would have to solve for this equation in terms of what? In terms of x instead of y. So if you were to do it that way, it would be like this, cx dx dy. And this equation here is going from x equal 0. And what is x on the line? When x is on the line, this line is still y equals minus x plus 1. So that means y minus 1 would be minus x, or x would be 1 minus y. And where do you have horizontal contributions? Everywhere from where? Here to here. So if you prefer to integrate dx first and then dy, then Calc 3 would give you this setup. If you do dy first, which I routinely do, then you have this setup. And what do you know? When you integrate over the whole triangle, this equals 1. So let's finish it. I'll go with this one. So when I do the first integration, the c comes outside either way. You're integrating dy, so the x goes outside, and you're just integrating dy. And you're integrating dy from 0 to 1 minus x. And then when you're done, you're integrating dx thereafter. We're doing this one, not this one. Okay, well, when you're integrating dy, you just have c, the integral of x, y, evaluated between y equals 0 and y equal 1 minus x. And then you have to do the dx integral. So when y is 0, you get nothing, but when y is 1 minus x, you get c x 1 minus x dx. And the last integration is 0 to 1. And what do you have here? You have c, and then you're integrating x, so that would be x squared over 2. And then you're integrating x squared, so it would be minus x cubed over 3. And you're doing that from x going from 0 to 1. So at 0, you get nothing from this, but at 1, you get a half minus a third, which is what, a sixth? And so this equals 1, so that implies c equals 6. Does that make some sense for the first part of it?
Yeah, that makes sense.
Okay, so let me see where we were then. Let me go back to it. Okay, so what I've just gone through. Pop up, I can't get rid of, but I can move it, so I'll do that. So we just got c equals 6. And now what? The rest of the problem was to find, I want to save changes to this. No, I don't.
Hit cancel.
Cancel doesn't help either. uh, you want to save changes to this in page 2. How about close? Nope, won't let me close, won't let me cancel. And now I've lost it. Oh, this is just a lot of fun. Let's see if I can reshare it. Oh, it's there, but I've lost it, whatever was there. Oh, So I will just go back to where it was. And get there. I think I just got too many things open. That's what. Tell you what, let's just do it from fresh if we can. So let me see whether I get back. Lost you guys. Can you hear me still?
Yeah, I can still hear you.
Oh, good, because I thought I actually lost you. Um,
Professor, did you want me to try to share the solution page for 5 again? Or
I've got it. I just got to see if I can share it. And I'm looking at it a little bit too. So the next part was part B. We got C. Next part out was just integrating out one of the variables to get the remaining density. So I'm looking at it. I'm just hoping I can share it. Let's see. Once again, you can hear me
yeah.
because I can't see you guys anymore. And I'm not sure why, except maybe I've got too much open. Um, hey, I'll take your offer, Edgar. Go ahead. If you could share it, do it.
Can you see it okay, Professor?
I, I see an ad for Florence Stanley. Is that something you brought up, or is it just my computer giving me headaches?
I'm not sure what that is actually.
Neither am I.
I just have the photos and of the key in the Zoom.
Well,
You stop sharing it
I
then.
see the screen properly. I don't see an ad.
I
I
don't
think
even I don't even see. I'm amazed you guys are with me because I don't even see the Zoom. I guess I found no, so I'm in trouble in terms of. Let me just see if I can refresh. So I'm just going to go back to. I think my. I think Zoom is unhappy with me in some way. And let me see. Oh, I think I'm back. Somehow I was gone. Maybe someone's trying to tell me something. Yay, I can share, at least in theory. Yes, you're back. I can see you guys. Thanks for hanging in there. Okay. All right. Now, do you want me to try to share it, or do you want Edgar to Edgar, do you want to bring it up again? Maybe I can see what you had. But I lost you all somehow.
I could, I could try it again. I don't mind.
All right, try again. Let's just see. Because I'm afraid if I mess around, I don't want to lose you again. So in theory, you would think I'd be able to reshare what I was just looking at in my solution.
Can you see the screen okay?
I just see all you folks. I don't see your screen. And let's see behind. I don't see. No. Well, maybe I should try to share. What do you think?
Yeah. I think that might be better because I don't know if it pops up or not.
Yeah, I'm not seeing it. So let me just see if I can share. Okay, so I have a host of things here. That's probably the problem. I've got too much junk. And of course, what I want to share isn't there. Let's see. So I will try this one more time. There it is. Let's see. Well, since I'm not able to share it for some reason. Oh, wait. That's encouraging. Okay, I can see it, but I don't know if I can share this with you. You don't see it on the screen, right?
You see it on the screen, it's just a little bit smaller, but it's on the screen.
Let me see if I can. Wish I could enlarge it, of course. Well, if you can see it, how do you find the density? How do you find the density for y? You integrate out the density for x. So we already know what the joint density was. It was 6x, right? Because we just figured out the 6 from part A. And so now we're integrating, but you're integrating in the, if you want to find the density for y, you integrate out the joint density with respect to x. So you're integrating 6x dx. I hope you can see it. It's very small. But again, if you have the solution set, maybe you can just look at that. I'm having trouble sharing it, I think. And then why are the limits going from 0 to 1 minus y? Um, the reason for that so let's see, it's 6x. Let me go back to, if I can, if I get to OneNote, that would work. Okay, so apparently I'm going to give up on that and just go back to OneNote. If I can do that, that'll work. Yay. Okay. I'm back to OneNote. So we're here. We know that the joint density is just, what was it, 6x when x comma y was where? In the triangle? And it's 0 otherwise, right? And the triangle looks like this. This is the x-axis. This is the y-axis. This is 1. This is the y-axis up here, so I'll just write it up there. And this line we already have seen is y equals minus x plus 1. Or, if you prefer, you can flip it around and solve for x. So y minus 1 y minus 1 is minus x, which means x is equal to what? 1 minus y, right? Yeah, okay. So you could write the line this way. You can write the line this way. It doesn't matter. Either way, it's this thing. Now, if you're trying to find the density for x, are we trying to find x or y? Help me out. Which is the first that they do? Just let me know. I think,
I believe we first integrate out x to solve for y.
yeah, but something bothers me here. If you want to find the density for x, what you should do is take the joint density, which is 6x, and you should integrate out y. If you want to find the other guy, this guy, then you should integrate out dx. Each time you're integrating out the joint density, but let's see, which of these do we want to do? Which is done first in the solution set? Is it this one first, or is it this one first?
This is the second one.
Okay, then let's do the second one first. Okay. So we're trying to find the individual density for y. We have to integrate out the joint density. And y, when we're integrating in the x direction, we're going from minus infinity to infinity. Here's how to visualize that. This is where minus infinity is for the x-axis, where positive infinity is for the x-axis is way over here. So when you're integrating from here to here, there are three possibilities. You could be hitting the region where the density is defined. That's the most interesting case. And if you so if we're doing this one, how would it go? Well, over here, okay, here's how it would go. You would go from minus infinity to 0. Why? Because in this region here, the density is 0, right? You're not in the triangle. So you're integrating 0, really, not 6x there. But then when you hit the triangle, you're hitting 6x and you're integrating with respect to x. And that's going on from where? From here until here. So that's going on from 0 to what is the x value when you hit this line? When you hit that line, the x value is 1 minus y. Is there more? Yes. but it's nothing because the rest of the way you're out here, you're off to infinity, and the density is 0. So it doesn't amount to anything. So you're going from 1 minus y to infinity, 6, well, it's not 6, it's 0 then. Okay, so when you're integrating over the whole region from minus infinity to infinity of the joint density, this is actually, I really shouldn't have written it that way. I really should have written it, put in the joint density. And then each time you'd be integrating over the joint density here, and that region is 0. Over here it's 6x, and over here it's 0 again. And the reason for that is you're integrating over the whole horizontal line from minus infinity to infinity. Well, these two will be 0. If you integrate 0, you get 0. So the only thing that survives is the middle one. And in the middle one, fy, middle y, you're integrating from 0 to, what did I say, 1 minus y, 6x dx. So you do the integration. The 6 comes out as a constant. This becomes x squared over 2. And then you evaluate it from x equals 0 to x equal 1 minus y. When you put in 0, it gives you nothing. When you put in 1 minus y, you have, well, 6 divided by 2 is 3. And the x becomes 1 minus y quantity squared. Hopefully that's what I have on the answer sheet.
Yeah.
Questions about that method? It's only one of the two. I think I got to do the other one. But do you follow what I'm doing?
Yeah.
Any questions about how I got this? So the picture is this. The density takes its values on the triangle. But to find the individual density, you integrate over all the values from minus infinity to infinity. But most of the time, you're integrating 0. The only part that amounts to anything is the part in here. And here you're going from x equals 0, which is the equation of this line, to whatever it is when it hits this line, which turns out to be x equals 1 minus y. And that became the upper limit here. Okay, let's do the other one. How would you get the joint density for y, or not y, x, sorry. Well, you would integrate over minus infinity to infinity the joint density, and you integrate out the y variable. Okay, that's pretty much the definition of how to get the density, the marginal densities. How does the picture look? Well, you're integrating from minus infinity to infinity with respect to y. So instead of going in a horizontal direction, you're going in a vertical direction, like that. Where's minus infinity? Way down here. Where's positive infinity? Way up there. And somewhere you're crossing the triangle, maybe. Maybe not. If you were integrating over here, you would never hit the triangle. And if you were integrating over here, you would also miss the triangle. So all the cases could occur. So how do you do it? You do it just like we did the last one. You go from minus infinity to infinity. Well, let's see. I mean, the first case, you break this up into different possibilities. So you could I'm trying to figure this picture. So you're going from minus infinity to this. So in this case, you'll be integrating 0 until you get to x, until you get to 0, really. So you could do this to 0, and on that part of it, the joint density is 0 dy. And then you cross the triangle right here, and you're integrating from where? From y equals 0 to when you cross this hypotenuse, and the y value there is 1 minus x. And in that region in the triangle, the joint density is what? 6x dy. And then you're integrating from where? 1 minus x all the way out to infinity. And there the joint density is 0 again. So I'm breaking this improper integral into 3 pieces, and I'm thinking of it going from minus infinity up to when y is 0, which is when you cross the x-axis, then going from y equals 0 to where it hits the hypotenuse, and in there it's 6x, and then the rest of the way is from here to off to infinity, which is 6x off to infinity, but not 6x off to infinity, it's 1 minus x off to infinity, but up here you're integrating 0. So what does it all mean? These both go away. Now, by the way, this is only assuming that the integration crosses the triangle. It's possible that you were integrating over here or over here, in which case you wouldn't hit the triangle at all, which means you'll get nothing. So you have to take into account where this vertical integration is going on and whether it crosses the region where the density lives. That's where you get contribution. If it misses the triangular place, there's nothing there. So let's see, we're almost done. So what's left is just this. So you integrate that, you'll get 6xy. Why? Because you're integrating dy, so x and 6 are constant. And it's y going from where? 0 to 1 minus x. When you put in 0, you get nothing, but when you put in 1 minus x, you'll get 6x 1 minus x. So that should be the answer. It should be, so all of this, so conclusion, the marginal density of this should just be 6x 1 minus x. But when does that occur? That only occurs when the integration line is taking values between x from 0 to 1. Okay, so that's the other one. Save me a chance. Let me stay on one note. Is this what we have on the solution set? I hope.
Yes.
Okay. Now, I think I'm more or less done with this problem, except one could always ask, how do you know it's right? Right? There's always the question of checking. So there's this one. And by the way, what should have been the values for y here? This one we integrated in the x direction. So we're only going to cross the triangle whenever y is between what? 0 and possibly up here at 1, right? So this comes with an interval too. Let me see if I did that right. Yeah, we're integrating out this one, but I should have said when y is taking values from 0 to 1. So they all come with when they're appropriate. Okay, how do we know they're right? Let's do this one first. If it's going to be a density, It lives on the interval 0 to 1. That's what this says. On that interval, it won't be negative, right? Because x is between 0 and 1, so this will be non-negative. And because x lives between 0 and 1, this will be non-negative. So it'll never be negative. So that's one check. And then the other check is, does it integrate to 1? So if you integrated this, we are really integrating 6x minus 6x squared from 0 to 1 dx. And the question is, do you get 1? To be a density, that has to be yes. And if it's not 1, then we made a mistake. So you do the integration, that's 6x squared over 2, reverse power rule, minus 6x cubed over 3, reverse power rule. Evaluate this between x equals 0 and x equals 1. So this is, when you put in 0, everything goes away. So it only matters what x is at 1. So this is 3 times 1 squared, which is just 3. And this is 2 times 1 cubed, which is just 2, and yay. Why is it yay? Because it's a density. Okay, so I've checked that this thing that came out of this integration that I described, I've checked that it actually works because it's non-negative and it integrates to 1. Are we done? Yes and no. How about checking this guy? Okay, if you wanted to check this guy, you'd have to look when y is between 0 and 1. Is this ever negative? No, it's a square times 3, so it's never negative. But does it integrate to what it should integrate? It should integrate between 0 and 1, 3, 1 minus y squared dy. If life is right, this should be 1. Question mark, is it? Okay. Well, you can pull the 3 outside. How would you integrate this? I think I would just do the reverse power rule, just being careful. Maybe a guess and check. Let's see. I sort of factored out the 3, then I'm raising the power divided by the new power. But when I differentiate this stuff, do I get this? Well, the 3 would come down. The 3's cancel. This would come down. You get a 2. But then you'd have another minus sign inside, right? So it looks like this would be the best second guess. So I'm thinking to do this integration that this is correct. And the 3's cancel, so I have minus 1 minus y cubed, evaluated between 0 and 1. And the question is, do I get 1? When I put in 1, I get nothing. So the upper limit doesn't give me anything. But when I put in 0, then I get 1 cubed, which is 1. There's a minus here and a minus from the lower limit of integration. And again, hooray, it works. It actually integrates to 1, if you think about it right. Okay, so now I'm more confident that I did it correctly. Does this help? Am I talking to myself?
Yes, this helps.
Oh, I heard someone. It was very faint, but at least I heard someone. I hope it makes some sense. I'm happy when I'm on OneNote. At least I can explain what I'm doing instead of trying to make sure the software doesn't conflict with each other. Okay, so what did we do? 3 problems. We just finished. Is there any more to 5, or is that it? Just tell me, because I don't want to look it up again. Every time I look it up, it takes a price.
It asks for the distribution and density function of u equal to x plus y.
I'd ask for, oh, I was going to say, was it going to ask me if they're independent? Is that in there too?
Yeah. It asks for the marginal densities and if x and y are independent for b.
Okay, let's finish that one and then I'll come back to the one you said. So independence would mean what? It is the joint density, the product the marginals, right? This has to hold for all x and y. Okay, now sometimes if you're off the triangle, then it's gonna trivially hold, because off the triangle the joint density is 0 and each of these are 0 as well. So that case is sort of something worth mentioning, but it's not the hard case. The harder case is 6y, which is what we determined was the joint density. Is that the product of these guys? I don't know. F of x is this, so it's 6x times 1 minus x. 6x times 1 minus x. And f of y was what? 3, 1 minus y, quantity squared. 3, 1 minus y, quantity squared. Is that right? I think it's right. Let me just make sure. 3, 1 minus y, quantity squared, that's between 0 and 1. So this is for y between 0 and 1. And the other one for x is where? X between 0 and 1 too, I think. Yeah, x is also between 0 and 1. Okay. Well, it doesn't look like it to me. I mean, I don't know. This looks like 18 x, 1 minus x times 1 minus y, quantity squared. This on the left looks very simple, and this looks rather complicated. So yeah, I think it would be probably not hard to find a place where this doesn't work. How about, let's pick a place in this triangle. So how about some place interior? So maybe x equals a half, and y, well, y on the line would be a half, so let's pick it to be a fourth. So how about this point here when x is a half and y is a fourth? Let's see what it gives there. I'm just sort of making it up because I don't think it's going to be hard to find one. So x equal a half and y equal a fourth. And when x is a fourth, when y is a fourth, this side becomes 6/4. And what does the other side become? X is a half. 1 minus a half is another half. 1 minus y, y is a fourth, so that's 3/4 squared. Are these equal? No, don't think so, but who knows? So this on this side is 3/2. So that's the whole question. And this is 2 times this would be 9/2 times 3/4 squared, which would be 9/16, right? Okay. And so what is all this? I don't know. 81 30-seconds. This is bigger than 2, and this is less than 2, so they're not equal. So what's the answer? No, not independent. Okay, now in order to be not independent, all you have to do is find one point where the product of the marginals doesn't equal the joint density. And I found one. I'm sure there are many others. Okay, so that's how to do it, but intuitively, why is it true? Well, I'll tell you why it's true. If you're in this region, suppose you're close to 1 in the x variable, you're close to 1, you're near this vertex over here. Does that affect what y could be? Yeah, because you can't be much bigger than 1 Well, you can't be much bigger than 0, right? Because if x is close to 1, y is close to 0. And that's really telling you that if you're in this sort of these corners of the region, it's particularly this corner or this corner, what x does limits what y does, and vice versa. And if x predicts y and y predicts x, then they're not independent, right? Independent means no matter what x is, y could do whatever it wants. So that's sort of an intuitive explanation. So anything that's on a triangle, probably, where you have these geographic restrictions that if you go close to the vertex here, the other one gets close to some other number, that's probably not going to be independent. Okay. Now, what else did I ask on this?
There's a part C to the question.
Okay, what does it ask?
Determine the distribution and density functions of u equals to x plus y. The random variables x plus y.
And I know how to do it, but we didn't have time to do it, so don't worry about it. I mean, it's a good question, and if we had a little more time in the semester, we probably would have got to it, but we didn't. And I'm not gonna start teaching you something brand new now and test you on it in a day or two. So don't worry about that one. It falls into the same category as your first request, number 1, where we just simply didn't get to that topic. But it's a reasonable question, by the way. If you know what x and y are doing, can you describe the density for the sum? And there are methods to do it, but not now. Okay. Anything else to 5? Okay, sorry for the delays. The technical problems were plaguing me here, but I appreciate you hanging in there with me. Is there any other problem on the test or any problem from homework or class that you want to talk about?
Can we also go over number 6 if possible? For the
Number 6, sure. What is, let me see. You want to tell me what 6 is? I'd rather stay with the OneNote, where I'd almost rather do
That's
the
fine. I could break it down.
Sure, tell me what 6 is about.
So it's basically the random variable function has a density function, and it's a piecewise function of 4 different intervals.
Okay.
So f of x is equal to that. So it's equal to 2x on the interval 0 to 1/2. One on the interval 1/2 to 1. Negative 2x plus 3 from 1 to 3 over 2.
I'm sorry, say that again.
On the interval 1 to 3 over 2,
Got it.
and then 0 otherwise.
Okay. And what do they want to know?
For part A, it's determine the distribution of the function.
Okay. What's part B?
It has a figure of a triangle, and then supposing a uniform joint density with random variables x and y.
Yeah, that's a little vague. Is there a part C?
What happened? I'm sorry.
Is there a part C or is there just an A and B?
For part B, it's just A and B, and then it says determine the distribution function and density function of u to y plus x.
I think that fits into this again.
Okay.
So that's going to
Part
be,
B.
yeah, I don't think we're going to do that, but we can look at this much of it.
Okay, no problem.
Yeah, let's look at that. So on 0 to a half, it looks like y equals 2x. Y equals 2x is a line with slope 2. So over here at 1/2, it would be 1. And then from 1/2 to 1, it's constant. And then from 1 to 3/2, it's a line, and it's a line going down. And I'm guessing it's going to look like this. Let me see. Yeah, because the slope, this line would, what's the slope there? You're going up 1 and you're going down 1/2. So that slope is -2. And I'm sure it intersects up here at +3. So I think it looks like what I've drawn. And then the rest that's it, right? Okay, so that's the density function. So that's y equals f of x. Let's make sure it's a density. Well, it's certainly non-zero. It's non-negative. Over here, it's 0 otherwise. And then in here, let's just check and make sure the areas add up. So this is 1/2 by 1, so that has an area of 1/2. This is a triangle, 1/2 by 1, 1/2 base times height would be 1/2 squared. And this has another triangle, 1/2 base times height would be another 1/2 squared. So this thing is actually, I guess, technically speaking, it's a trapezoid, but it doesn't matter for what we're dealing with. 1/4, 1/2, 1/4. The area is 1, so it is a density function. Okay. Now the first question is they asked what's the distribution function? That's an interesting question because that's something we did play with a little bit, but not a lot. So I can't quite tell you just forget it like I did on some other problems. Like that other one this one, I just said, don't worry about it. Okay. This one we could actually worry about a little bit. And what is the distribution function? Distribution function of a random variable was this, the probability that x takes values to the left of it, a number. That's called the distribution function. So I'll do this. I don't think it's as high in demand as a lot of the other stuff we've been talking about, but I don't mind doing it, and it could be something that you actually know how to do. So it has more possibility of being on the test than certainly this, which I told you don't worry about at all, and certainly problem 1, which I told you to forget. But I wouldn't say this has any higher probability than what we just went over. So for example, to find the joint densities of x and y and to see if they're independent, that'll be there. So the problem we just went over is more likely to be there than the problem you're asking, but it's not where I can just say forget it either. Okay. So let's see what it would be. So this is the definition of a distribution function. So it starts easy. It depends where x is. If x is over here, so when x is, say, less than 0, the distribution function tells you the probability of being to the left of that number. But there's no density function over here. The density function is 0. So when you're to the left of 0, there'll be no probability there. Okay, so that's an easy one. What's the other easy one? The other easy one is suppose X is over here. What's the probability you're to the left of that number? Well, that's the whole area underneath this thing, which we already checked is 1. So that's the other extreme. It's 1 when X is what? Oh, bigger than 3/2. Okay, so those are the extremes. So those are the easiest ones usually to do first. Now, there's a couple there's one more that's not too bad. This one's not too bad. So what am I doing? I'm looking at different cases. X could be to the left of 0, X could be to the right of 3/2. Now I'm considering the case, suppose X is between 0 and 1/2 somewhere. So, okay, make that an actual case. When X is between 0 and, what did I say, 1/2? Yeah. So when you're in there, well, how much probability would there be to the left of that number? It would be everything in the triangle that's captured in this shaded region. Okay, so what would that, how much probability will be in there? Well,
A fourth?
well, it depends where X is, right? I mean, if X is close to 0, there wouldn't be much, right? If X is closer to the half, it would be closer to, it'd be closer to the fourth that you mentioned, right? Okay. So it can vary. So what we really need to do is integrate, I think. We have to integrate all the area that we're talking about is happening between 0 and X. And what's the density function? The density is 2X. Okay, but this is sort of a prescription for disaster. If you put X as a dummy variable in the integral and a real variable in the outside, that's confusing at best and could lead to the wrong answer. So what I would do is put in an integration variable, which is different than X. Doesn't matter what the variable is in here really is. It's a variable of integration rather than a real variable. But you're trying to find out how much area there is in this part of and under this part of the density. There's nothing here to the left. So everything to the left of X really occurs in this little triangle. All right, but it's not hard to figure it out because you can just integrate this. The 2, it goes outside. You integrate t, you'll get t squared over 2 and evaluate between 0 and X. When you put in 0, everything goes away. The 2's cancel anyway. So what do you really got left? Just X squared, right? So that's this part. Okay. It's not hard, but I don't think we've done it lately, if at all. So, but since you asked, let's finish it up. We're 3/5 done. We've got 2 other cases. What are the 2 other cases? Well, the other case is X is, we said far left or far right. Those were the easy cases. Then we did this one between 0 and 1/2. Now let's pretend that X is in here somewhere. Now, if I really wanted to be careful, I would erase all the other X's so you wouldn't get confused. But I'm hoping you're with me, realizing that I'm just treating different cases of where X could be. And if I leave them here, then I know I've already done them and I don't have to worry about them. So what's left? I have to do 1 between 1/2 and 1. I have to do one more between 1 and 3/2. So let's do between 1/2, 1 and 1. When X is somewhere between 1/2 and 1. Is that where I'm really located? Let me go back up and look at my picture. Yeah, that's right. Okay. So, but the distribution gives you all the area to the left. So what would it actually give you in this case? I'm going to erase this X just for the moment because I want to do this case from scratch. Yeah, can I get rid of that little? Yeah. So if X is over here, what's the area to the left? Well, I don't want to make it sound like half of it's here. Half was under the whole thing, right? So what I have to figure out is the area under here up to X, and then add to it the area up to here. There's no area over here to count. Okay, so I'm trying to, distribution counts all the area to the left of the number. So I could already do this one. In fact, I think we already did it. Let me see. When X was 1/2, then this became a fourth, right? So the area in here was 1/4. It's hard to see with all my hatch marks. But I could see it just by putting a half in for X, I'll get a fourth. That's from the part we already did. But now we have the part here that's shaded between 1/2 and X. And how can we find that? Well, it's not hard because we're really just trying to find the area in this rectangle, because this is a rectangle, the height is constant 1. And so the area within the rectangle would just be length times width. The height is 1, and the width is what? X minus a half? That's the width. So X minus a half times 1 is just X minus a half. But that's just the area in the shaded portion. Then you're going to tack in the part over here, which is a fourth. So this one's trickier. It's X, help. 1/2 minus a fourth is a fourth. So this is what, minus a fourth? Is that right? Yeah, I guess so. Let's test it. So how can you test this? Well, if you were at 1, then this would be a half times 1, which is a half, and then this another fourth would be 3/4. So at 1, you do get 3/4. So that looks right. You don't have to put all the evidence of it. You can just put this there. You know. So we've done 4 out of 5. What's left? What's left is X could be over here between 1 and 3/4, 3/2. So if X is over here, what are we counting? All the probability to the left. That's what the distribution counts. So it would be everything. It would be everything in this triangle, which we already knew was a fourth. It would be all the area under here, which we already knew was what? A half. And then it would be the area in here, which we don't know. But we sort of do, in a way. We could certainly integrate it if we wanted to, but we needn't, because the area into here is something you could figure out. How could you figure it out? Well, it's a trapezoid. So if you want, you have a choice. You could do calculus and figure out the area here, and then add it to these two. And that would be all the area to the left. Excuse me. Hey, what's going? Yeah, I'm not quite free, but I think I'm on my last problem. Okay. All right. I'll talk to you later. Yeah, no problem. I'll be happy. I'll be happy to help. Love you. Bye. Okay, that was my wife. So my window is coming here. Okay, so where are we? We're trying to finish this baby off. And what's left? Well, we're in this case where X is here, and we want to know all the area underneath the density to the left. So it comes down to how much area there is in here. And I think, do you remember the area of a trapezoid? This is a trapezoid. Trapezoids have what? They're quadrilaterals that have one set of parallel sides and the others don't have to be. Parallelograms are special trapezoids, but in general, they have two bit bases, base 1 and base 2, and there's usually a height here. And a formula that you probably learned back in some place, high school, middle school, whatever. The volume of a trapezoid is you average the bases and then you multiply by the height, which makes a little sense if you think about it. So that's a formula from pre-calc. Might as well use it. Well, all right. What would the height here be? The height would be this thing. So that would be x minus 1. That's the height. What are the bases? Well, one base would be going from here to here, which is 1. And the other base would be going from here to here. But where are you going up to? You're going up to this line. So that would be 3 minus 2x. Which is the height of that line. And then divide the whole thing by 2. So what I'm suggesting, the answer might be, is this stuff. So what is all this? I don't know. 1 and 3 is 4 minus 2x all over 2. And then this was what? X minus 1? And can that simplify? Yeah, the 2's can be canceled. So you got 2 minus x times what? X minus 1. That seems to be the area in here. But then that's just the trapezoid part. Then there's this part, which is 3/4. So I would tack on another 3/4 to this. So the last one on this guy, well, yeah, actually, you can tell me if tell me if this agrees with the solution set, because I don't want to go try to find it again. But what I'm getting is 3/4 plus 2 minus x times, what did I say, x minus 1. And that's just this, and then another 3/4 is there. So I guess that's it. And this is what it is when what? When x is between 1 and 3/2. All right, so I haven't been looking at the solution set. Does this match what's in the solution set or no?
Well, yeah, the functions just the functions match. It's just the last one we did is just not in factored form, but it looks the same.
Okay, cool. So that's how you find a distribution function. By the way, if you have the distribution function, it's much easier to find the density. All you do is differentiate each of these guys. So if you differentiated this, you'd get what? 2? Well, wait a minute. Yeah, if you differentiate this guy, you just get 2. And why is that not the density? I'm bothered already by that. Let's see. Oh, this is I think I mislabeled this. Shouldn't I call this capital F? Yeah, the distribution is called capital F of X. And I'm saying, oh, but I'm seeing, oh goodness. So I mixed them. I must be getting tired here. I'm sorry. So originally this was the distribution function, right? So I should have done it down here. My bad. This was the distribution function. So where did I mess up? This thing should be put in the other place, right? Sorry.
Yeah, sorry about that. Yeah, I think so.
That's my problem. Okay. So, all right. So I think, and I didn't think about it because it didn't look like there was much room here, but this is where it should go. Yeah, but now that I've just destroyed it, it's 3/4. So it goes in here, right? 3/4 plus the product, the weird product I had there.
2 minus x and then x times x minus 1.
Yeah, 2 minus x. 2 minus x times, what did you say? X minus 1.
Yes.
And that's what you get when x is greater than or equal to 1, but less than or equal to whatever, 3/2. Yeah, it's a good thing I checked because I started to mess it up. I've started to mess up little f and capital F. So what I was trying to say is if you have capital F, it's much easier to get little f. Derivative of this will be 0. Derivative of this will be 2x, and that matches this. The derivative of this one will be 1, and that matches this. And, well, I don't really want to do it, but I'm pretty confident if I took the derivative of this stuff, it should equal to this. And it makes some sense because this is a quadratic, and when you take the derivative, you get a linear function. And let's see. And those are the only 3 parts here. Everything else is 0. And it should have been, the rest here should have been 0 otherwise. And as far as that goes, yeah. So this thing, if you graphed it, it would look like 0 until you got to 0. It would have a quadratic, whoops. Try it again. It would look like this. You got to 0, it would start going up like a quadratic, a parabola. Then it would start leveling off somewhere in between. So you'd have a line that's got slope 1, becomes linear, still going up. And then this is going to be a quadratic going down. Something like that. And the whole area in here is going to be 1. And when you're further away, it's just going to be 1 to the left or more. So the distribution function should look something like this, roughly. This is a linear part. And then this is quadratic going down. Cool. I think I'm ready to quit. What about you guys? Did we cover most of the stuff on there?
I think so, yeah.
I hope so. I hope someone was recording this, except for the part where I couldn't get the software to work.
I recorded
Did
pretty
you?
much the session and I paused it when we had
Oh,
Yeah,
thank
yeah.
you. When I had troubles. Good, thank you. That's even better because I guess I could have been grunting underneath my breath here, just thinking, how come I can't share this stuff? Anyway, I'm gonna quit. I'll see. I wish you all. Is there anyone else who happened to show up who's from the morning class who wants to know their grade on the second midterm? I'm not sure. I started the session off that way because I was happy to get some of the grading done. I don't have the grades done for those in the afternoon session. I'm hopeful I will by the time of their test. So I guess last thing I'll mention So for for the morning people, the people from my 11 o'clock class, our our test is Wednesday at 11, right? Same room, same time. Except it goes 2 hours and you'll have an extra hour if you need it. But for the people in the afternoon session, your final is on Friday. And we've changed it so that it's not at 1, it starts at 11. So if you're in the afternoon session, please try to get there 2 hours before it appears like you're supposed to be there. We're trying to get there at 11. I have a conflict on Friday is the reason for that. And I know I have one person doing it on Thursday. And if anyone has any special circumstances that I need to know, let me know. I'll hang around a few minutes. And now let me be brave and see how many people actually are still with me here. If I could even see the screen of people. Okay, I can't even see you. But I assume you're out there. So is there anyone who wants to talk to me? Should I hang around for anybody?
I didn't realize when you were asking earlier, but I'm from the morning class and I didn't get my
Oh, you want, okay. So the easiest way I was doing this without telling everyone your score over the line is if you can just shoot me a quick email right now, and I'll respond with your two-digit score.
Okay, I'll do that right now.
Yeah, and that goes for anyone else who wasn't here when the session started and would like. And I actually have a couple scores from the afternoon people, but I think one of them already got it. Let me see who score did I have from that. Blake Kneebone, I've got your score if you want it. And Jason Kwan, I think I already told him his score, I believe. Those are the only two from the afternoon class I have. I assume you just took it with the morning class, and that's why I happen to have it. All right. Good luck on your finals in general.
Thank you so much, Professor.
Thank
Thank you for
you.
the review.
You're very welcome. Yeah, I'm sorry I can't see you in person to say goodbye, but right now I'm not going to push my luck. I still have to see how to shut this thing because right now I don't even see how to shut it, but I'll figure it out. Take care.
Have a good night.
See you
Yeah.
later. Have a great night.